The first shader I would like to show you is called Scalar Matte Unary. This shader can be found under Matte, under the Scalar Unary right here. The shader is designed to take the input and apply a matte operation. In this case, it could be absolute, negate, or invert. Let's show the actual impact on the displacement map whenever we connect this shader right here on displacement. So now what we have done here is actually did a negate. Negate means that any positive value will become negative. Now if we go invert, every zero value basically will become 1, and any value that is 1 will become 0. It's kind of a swap basically. Now if we go to absolute, absolute in this case doesn't have any impact on the output because absolute is only applicable to negative value. Because the input varies between 0 and 1, then obviously there's no place to do the actual absolute function. Now what I'm going to do is go here and actually disconnect this shader, connect it to displacement map, and go in the gradient shader and insert a marker and set a negative value to the marker. So as you can see now, it will go from 0 to -1 to 1. Now what if I connect the absolute shader or function, you'll see that basically any negative value will become positive. So this is the absolute function from the Scalar Matte Unary. The second shader I would like to show you now, it's called the Scalar Basic node. It allows to create a basic math operation like, for example, add, subtract, multiply, divide, minimum, maximum. Let's see how this shader allows to affect the actual displacement map. So let me connect this shader right here. What you could see now, I'm basically adding 1 to the displacement map. So it's going to push the value by 1 unit. If I make it 0, it will have basically no impact on the displacement map. So I can actually start to offset these values. So for example, if I say -0.5, it means that the actual displacement map will be pushed by -0.5. So it will actually, any white values or bright values will go to 0.5 to -0.5. So this is a way to actually make sure that the displacement map stays within the actual surface limit and does not go outward by a lot of units, let's say for example 1 unit. So it allows to actually offset the entire displacement map towards the actual surface. Now the other mode is called, let me put this value to 0, and is called subtract. This is the same thing as additive, except that it's going to subtract -1. So now we can actually take this surface right here and push it by -1. So as you can see, if I type 0.5, it means that it's going to push the surface or move the surface inwards by 0.5. It is basically the same thing as add. Now in terms of multiply could be used as basically a sort of scaling capabilities or scaling factor. So if we could say, for example, it's 1, so it's going to multiply the input by this value. So multiply by 1 means that if it's 1, it will return 1. If it's 0, it will return 0. Now if you could say, if you want to scale the actual displacement map intensity by 0.5, you could do it right here using the multiply by 0.5. You can also use this as a sort of invert, where you could say, okay, now I would like to have a negative scaling. So in this case, any displacement map value that let's say have a value of 1 will become now -0.5. So it's going to be scaled negatively. Same thing for divide. Divide is the same principle. So in this case, if you say divide by 10, then obviously it's going to divide the actual height by 10. So you'll basically have this sort of very slow slope right here. So if you divide by 2, this is the same thing as multiplying by 0.5. Now if I put it to 0, if you say minimum, so what is minimum is basically a clamp to max. So if I say 0.5, it means that the actual displacement map will go from 0.5 to 0 to 0.5, and then this shader will say, well, any value above 0.5 will basically remain 0.5. So this is a way to actually clamp it to a maximum value, where minimum stands for give me all the values below that point, which is basically the minimum value. If we go maximum, then in this case it's going to actually clamp the 0 to 0.5 values to a fixed value, and let this variation go on from 0.5 and above, so giving the maximum value above 0.5. So these are ways to actually create some sort of displacement map clipping. So for example, we could say 0.8. So now what we're going to do is actually just clamp it to extract a very precise portion of the displacement map. In this case, I'm just going to say 0.2, and I could actually get another math scalar basic and basically put this one here. I'm going to set it to this one minimum, and I'm going to say 0.9 or 0.8. And this way I'm going to, by connecting and these two shaders, I'm going to create a sort of minimum and maximum clamping by putting these two shaders together. So let's rename it correctly so we could see maximum, and this one is minimum. So as you can see, by connecting these two shaders one after the other, we create some sort of a minimum and maximum clamping with displacement map. Here's another matte shader that could be used for displacement map to control the slope of displacement map. You can go under matte, scalar exponent. The matte exponent shader has multiple modes: exponent, logarithmic, bias, and gain. We'll be focusing on bias and gain because these are the two common and most useful mode for displacement map. Bias and gain could be seen as contrast and brightness onto an image, except it's going to be applied on the actual input, which will affect the output. So let's start with bias. If we set the value to 0.5, the factor will determine how the bias will be applied. So 0.5 means that the actual input will not be affected. It will come out as unaltered. So as you can see here, I've set the bias to 0.5, and the actual slope here remains the same. By increasing the factor, you have a choice of either putting the factor towards 0 or towards 1. In the case of increasing to towards 0.9, you'll see that the actual slope will create this sort of curvature towards 0. So you will be able to control the actual grayscales or displacement map distribution over the grayscale input. If you set 0.1, the opposite slope will be created right here, where it's going to compact and create some sort of a curve towards values ranging around 1, 0, and 0.5. If you make it very, very small, obviously the actual slope will be more intense. Now if we put it back to 0.5, you'll see that the actual slope remains the same, because it's going to apply the bias, and 0.5 means unaltered, the same value. Gain is offers a different type of control, where it's actually going to flatten either vertically or horizontally the actual distribution or the displacement map. So let's say, for example, I type in 0.9. As you can see, the actual displacement map will be flattened horizontally. as I type in a value that is below 0.5, then the opposite will occur, where the actual displacement map will actually compact the displacement map towards some sort of vertical alignment. This is really good to control the actual slope of the displacement map whenever there's a very linear distribution of gray levels over a large area like this, for example. So if we type in 0.5, we'll get back exactly to the same value. I invite you to watch the other session that will talk in details about these two modes, especially on the real-life displacement map. So it is possible to enhance the displacement map without having to do any image touch-up on the displacement map. So you could do it live within the render tree using these nodes.